So the total internal reflection gives us that phenomena where a ray of light which is traveling in a denser medium is incident on the interface at an angle which is greater than critical angle. So what happens? This ray undergoes, it reflects in the same medium and hence it undergoes total internal reflection. This whole phenomenon is this. Now, why do we study this? Because of its practical application. There is a huge advantage of the practical application of TIR, but I will not mix two terms. There is a practical application, that is the applied knowledge of this phenomena which we use and for ourselves, for the sciences and the development of many things, which I will just tell you. The other thing is the naturally occurring phenomena related with total internal reflection. There are certain phenomena which happens in nature, but we do not take control of it, we do not make it happen, they happen automatically because of certain conditions, certain environmental conditions developed in the nature. So let's go through them first. So I would say, because I especially mention this point because in many books I have seen that it is written the practical applications of TIR, and after that they start with, the first one is the mirage effect. So the mirage effect is not an application, okay. Mirage effect is an natural occurring phenomena which is happened due to TIR, okay. So the mirage effect, what is this effect? See, I'll explain you. Suppose this is a land of desert, okay, and here I have a tree. Which tree? Palm tree or date tree? So this tree is standing at a region where temperature is really very high. So due to that high temperature, the sand, the earth part, the land part, this becomes really hot. Now what will it do if it is very hot? The air which is in contact with this land, I am just shading some land portions, okay. So this is my land. So the air which is in contact with this land becomes what? It also becomes hot. So what will happen? The hot air will start rising up, right? But after traveling some distance, after covering some distance in the atmosphere, this air is going to get colder or it's going to lose some heat, the particles. So what will happen? The air will be comparatively cooler at this height than at this point. Ultimately what is happening? There is a change in the density of air, gradual change, while we are traveling from this point to this point or from this land to the height, and the density of air is increasing. So whenever a ray is traveling from this point to this point, that means the ray is traveling from denser to rarer, okay. This much part is complete. So let's talk about this ray. I have a ray which is coming from obviously sunlight, and it is incident on the tree. It is reflected in this direction, but due to this temperature effect, the density changes. This whole region is divided into many small layers of what? Different densities of air. For example, the density of topmost layer will be maximum, whereas the density of the lowermost layer would be minimum. So this ray which is traveling from denser to rarer medium is undergoing what? It is going from denser to rarer, so then it will bend away from the normal. Instead of going straight, it will bend away from the normal. So similarly, at every point the ray tends to bend away from the normal and it keeps on bending. So in that process, what happens? This ray which is incident on the ground or on the sand, it is incident at such an angle as if it is almost grazing the land. This is the angle of incidence when it hits the land. So at this point, if it is this diagram, I'll make this point here, so it will be more prominently visible. At this point, the angle, this angle, what is the angle of incident here? This is the angle of incidence, right? So this angle is way larger than what? Critical angle of air and land interface. Here what happened? This ray, which is undergoing different layers, which is undergoing transformation through different layers and bending away from the normal at each layer, ultimately hits the land, and it touches the land at such that it appears to be like it is almost grazing the land. So at this point, this angle, it becomes really large, way greater than the critical angle of what? Land and air interface, and hence this ray of light reflects from this point, and it reflects at the same angle where at which it was incident. So the ray of light is going like this. So it will, for an observer for which the ray of light is going in this direction, if the observer is here, suppose this is my observer. So for this observer, the ray of light is coming from this point, and this whole tree will appear like this. That is, he will get to see the mirror image of this tree in that desert area, as if there is what? They will find as if there is water placed here. This is what mirage effect is. So no one is causing this phenomena. This whole phenomena is happening on its own due to some factors governing this. For example, heat, then the change in density of air, and then the critical angle of land and air interface. So this is what mirage effect is. There is exactly similar phenomena like this, but in case of water. This is called looming. I think most of you haven't heard of this term. This is called looming. I'll show you, I'll explain you in brief what is looming. First let me rub this. See, at ports or at seashores, if you see during dusk and dawn, you see the sun rising, and from the sea, sun appears to be rising from within the sea, right? And similarly during the dawn, sun appears to be going down the sea. During the daytime, suppose this is my seashore, okay, this is my coastline, and this is the water level. This much is the water level, this is the seashore, okay. Now I have a boat here. Let me mark a boat here. This is my boat, small. Exactly opposite to what we just studied in the mirage effect. Here the air in contact with the water is denser, and there are two things why it would be denser. First of all, the heat is getting absorbed by the water body, so the air would be comparatively cooler than the air present at height. Number two, the water vapor due to the sunlight heat, the water vapors or the vapors are actually adding up or filling up the density of the lower layers, right? So here the layers of air are what? This time this is the lowermost part is the denser and the uppermost part is the rarer, right? So the ray of light which is incident on this boat gets reflected, but this time the ray of light is again traveling from denser to rarer, so it will keep on bending away from the normal, and this phenomena will keep on happening till the point where the angle of incidence, at what point? When the ray of light is entering the another layer of the air from one layer which is higher or lower in density, or when there is an interface present between two different layers of different density, then this angle of incidence, this angle automatically becomes greater than the critical angle of air-air interface. Last time it was what? Land and air interface. This time it is air and air interface, but both the air layers are of different densities. So this light rays actually gets reflected due to the same phenomena from this point only, and the ray of light strikes here. So if there are observers here, they will find out that for them the ray of light is coming from this point, and the boat will be visible at this height. It will be appearing like a boat is suspended somewhere in the atmosphere, no connection with water, no connection with nothing. It is just suspended in the water for a while. So this phenomena do happens. This is called looming. Okay, so these are those phenomena which are associated with total internal reflection, but we are not causing it. What we are causing is called the practical application, and these are the topics or points which are to be considered under the applications. The first one is called glittering of diamond or brilliance of diamond. Now you can write in detail. First one is in the applications of TIR, glittering or brilliance of diamond. The basic reason behind the application is one, what? This thing, refractive index is inversely proportional to critical angle. Did we study this? Did we study this? No. Yes, actually we studied what? We studied this relation sin IC, which is critical angle is equal to 1 upon mu, and that makes critical angle inversely proportional to refractive index. Okay, that means higher the refractive index, lower will be the critical angle, and vice versa. Now in case of diamond, have you seen diamond in raw form, the rough nature form? Diamond is any random shaped stone. It's not a sharp edged, perfectly cutted diamond. It is of any random shape. Now when it is brought in the factory where diamonds are actually cultivated to shine, to glitter, they are gone through machinery processes and they undergo a lot of cutting and smoothing of edges. So this diamond is cut in such a way that basically what people do, they calculate all the angles associated with the cutting of diamond and they make such kind of shape. This is just an example. Okay, so they have removed this much part and you are left with this much part. So how TIR helps us in this? See, diamond is actually the hardest naturally occurring substance, right? Why? What makes anything so strong? So it is naturally what? It is the